All right, so we looked last week at experimental probability. We looked at experimental probability where we would roll dice and we would collect information and then use that information to predict future outcomes. We rolled dice, we spun spinners, we flipped coins, all in predicting outcomes of the future. We also looked at combining probabilities. So flipping a coin and rolling a dice, those sort of things. Today we're doing the same thing except for we're using theoretical probability. Theoretical probability is what should happen in theory. A coin will land on heads half of the time. And combined events, so multiple things happening, rolling 2 dice at the same time, for example. The idea today is organizing our data. Making our data easy to read so we can see all of our possible outcomes. One way we do that is with a table. We can use a table to show dice. We're going to roll 2 dice. So we're going to roll 2 dice, and we're looking for a probability of the combined sum to be 8. So when I add the numbers up, they equal 8. Now create a table. I'm going to start by listing out all of my dice outcomes. So 1, 2, 3, 4, 5, and 6. Those are all the outcomes of a dice. And then I'm going to do the same here on my Y. So 1, 2, 3, 4, 5, 6. So this is dice 1 and this is dice 2. Now I'm going to list out all of the possible outcomes. Now remember, we're looking for sums. So if I roll a 1 and a 1, the sum is 2. If I roll a 1 and a 2, my sum is 3. 1 and 3, it's 4, 5, 6, and 7. If I roll a 2 and a 1, it gives me 3. 2 and a 2, it's 4. 2 and a 3, it's 5. 2 and a 4, it's 6. Probably starting to see a pattern. 3 and 1 is 4. 3 and 2 is 5. 3 and 3 is 6. 3 and 6 is 9. 4 and 1 is 5. 4 and 2 is 6. 5 and 1 is 6. 6 and 1 is 7, 8, 9, 10, 11, and 6 and 6 is 12. So we created a table to see very clearly all of the possible outcomes. How many total possible outcomes are there when we roll 2 dice? Don't just yell it out. There's 36. What is the probability of rolling the sum of 8? Woody? So 1, 2, 3, 4, 5. Each of those combinations 6 and 3, 5 and 3, I'm sorry, what is that? 6 and 2, sorry. 4 and 4, all of those result in 8. So 1, 2, 3, 4, 5 out of the 36 will result in an 8. Now, if you were playing a game with somebody and whoever guesses the sum wins, would you guess 8, or is there one that would have a higher probability of winning? Michael? 7. If you look at 7, 1, 2, 3, 4, 5, 6. So 7 actually has 6 out of 36. So the probability of rolling two numbers that add together to get 7 is higher than two numbers to get 8. Creating a table from that allowed us to see all of those possible outcomes. The second way we're going to look at is a tree diagram. So let's look at a deli. They make sandwiches with bread, meat, and cheese. I'm sure they use other stuff, but that's all we're interested in. Let's start with bread. Allie, give me a type of bread. Wheat bread. Caitlin, give me another type of bread. All right, so there's two types of bread. Let's look at meat. Trinity, give me a type of meat. Jillian, give me a meat. Yao, give me a meat. Well, we already got turkey on there. Bologna. I think that's bologna. And cheese. Kaylin? All right. All right, so jalapeno cheese, Hunter? Colby. All right, so we're gonna stop there at combinations. So we've got meat, bread, cheese. Now we're going to use a tree diagram to illustrate all of the possible combinations in a clear outlined way. We're going to start with the bread, and I'm going to look at the first bread item, which is wheat. So if I choose wheat bread, there are 3 different types. There is turkey, ham, and bologna. I'm just going to do BOL. Oh my God. All right, so we've got wheat, and I could choose turkey, ham, or bologna. Now I could choose wheat, turkey, and jalapeno cheese. Or I could choose wheat, turkey, and Colby. I could choose wheat, ham, and jalapeno. or wheat, ham, and Colby. Or I could choose wheat, bologna, and jalapeno, or wheat, bologna, and Colby. So those are my possible combinations. Each one of those is a different type of sandwich. Wheat, turkey, jalapeno, wheat, turkey, Colby. Each of those is a different sandwich. Now we could also use Italian bread. It's really good. Italian bread is really, really good. All right, so you got turkey. You got turkey and ham, and we can choose bologna. And we can list out all of these combinations. So turkey and jalapeno, turkey and Colby. You could get ham and jalapeno, ham and Colby, bologna and jalapeno, and bologna and Colby. So my first question is, how many combinations? So how many different sandwiches could you get at this deli? Trinity?
7.
7 different sandwiches? It looks like more than that. No, because remember, Trinity, each one of these is a different sandwich. Wheat, turkey, and jalapeno is a different sandwich than wheat, turkey, and Colby. Oh, I see, I see. Hunter? 12 different sandwiches, yeah. Each one of these is one of the outcomes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 total sandwiches. What's the chance of randomly choosing Italian, turkey, and Colby? What's the probability of randomly choosing that? Josh? Perfect. What I say, Italian, turkey, and Colby? Yep. So that combination of sandwich is 1 out of the 12 possible combinations. Again, we're using a tree diagram to looking at the probabilities and making a clear, organized way to construct all of those possible outcomes. The last way is looking at a list. So with a list, let's break into a combination. The bike kit? Oh, yeah, it is. So the combination lock is a 3-digit code. So it's got like 3 little spaces here. And it's the kind where you can like rotate it to a different number, rotate. And there's 3 numbers. There's a 1, a 2, and a 3. What we're going to do is we're going to make an organized list to find all of the possible combinations that could exist. So the combination could be 1, 1, 1, or a 1, 1, 2. 1, 1, 3. Now the idea is that you want it to be an organized list so that you're not repeating any of your possibilities. By making this list, you're going to see a very clear set of outcomes. So I changed that third position, 1, 2, 3. Now I'm going to change my second position from a 1 to a 2, but I'm still going to rotate around these 3. So 1. I'm going to leave that middle position, a 2, and I'm going to still rotate that third position. My middle one stays a 2. My third one stays a 3. So if you notice, the only thing that changed from this set to this set was that 2. Now I'm going to do the same thing and rotate it to a 3. So I'm starting first by rotating my third place. Then I'm rotating my second place. So I've rotated my middle one to all 3 possible numbers. Now I'm going to rotate my first one. So I could have a 2, 1, 1, or I could have a 2, a 1, and a 2, a 2, a 1, or a 3. Notice my second all stayed 1. My first one all stayed 2. The only one that rotated was that third level. Again, my first one stays a 2. My second one now changes to a 2. And my rotates around. So 2, 2, 2, 2, 2, 3. So think of it as 3 different levels. There's 1, 2, and 3. 3 is constantly rotating. We're trying to get it to match up with the first and second level. The third level rotates the fastest. It rotates every single time. The second level only rotates after we've rotated all 3. That third level, that longest one, only rotates after we've rotated all 3 of the middle ones. So here we went from 1 to 2, tried all the 1s and tried all the 1, 2, 3. Notice the only difference between this and this is that first. The only difference between this and this is that first. So here I'm going to do 2, and now I'm going to have 3 in the middle. 1, 2, 3, 2, 2, 3, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now I've got one more column to make, and that's rotating that first one to a 3. So 3, 1, 1, 3, 1, 2, 3, 1, 3. Notice all of these are the same except for that first digit. Then I'm going to do 3, 2, 1, just rotating that middle one. 3, 2, 2, 3, 2, 3. And now I'm rotating that middle one more time. 3, 3, 1, 3, 3, 2, 3, 3, 3. So I've listed out all of my possible combinations. So if you own this lock, and you can change your code to anything you want to change it to, how many possible codes could you have? That's a lot to choose from. Nick, how many total combinations do you have to choose from? It is. It is. Woody, help him out. 27. Yeah, there's 27 different combinations you could have there. Now, if you were trying to break into this lock and you tried a combination, what is the probability that that first one would work? Yeah? Yep. 1 out of the 27. Good question. All right, I'm going to do another one that's a little bit similar. So bicycle. A bicycle license has 3 spots on it. Very similar to your lock up above. The bicycle combinations can be in any order A, B, and 4. And they can repeat. So for example, you could have A, A, A. You could have B, B, B. You could have 4, 4, 4. You could have A, 4, A. You could have B, A, B. You could have any combination of those. A few questions. What is the probability of 2 A's in your license? What is the probability of 2 numbers in your license? What is the probability of 2 or more B's in the license? If you like to work with somebody, you can.